Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing thin converging lens, paper 3 for core candidates, and we are having classwork. We will start by KWL chart. You have to write down what you know, what you want to know about converging lens, and at the end of our lesson write down what you learned. And please, back to specifications of our syllabus, you have to check that what you learned is here. Okay, let's start by question number 1. Question number 1, showing a converging lens to the left of which is vertical object AX with one end on the principal axis, and you have here, so here you have the object, and distance PF is the focal length of the lens. State the name given to the point F. Okay, this point P is called optical center, and point F is not labeled, but you know that the distance between the focus and the optical center is called focal length. So focal length is the distance between the optical center and the focus. So the answer of this one, state the name given to point F is called focus or principal focus. Okay, principal focus. On the figure, draw a ray from the top of object X, which is parallel to the principal axis. And then you have to continue this ray 6 centimeters after the lens to show how it will be refracted through air on the other side of the lens. Okay, we will draw the ray which is parallel to the principal axis, and it will refract through the midline here inside the converging lens. Okay, and again one more time, I told you while we were discussing paper 1 that refraction takes place at the boundary, but for simplicity we are refracting the light ray at this middle line. Okay, so this ray will refract through the focus. Okay, don't forget to show the arrow of refracted ray. So this is the first ray. On the same figure you have to draw another ray which will enable you to locate the image of X and label this image letter Y. Okay, the second ray, we will draw the second ray. It will pass through the optical center and it will be undeviated. So this ray passing through the optical center, and this ray is undeviated, no change in direction, no refraction, it will continue in a straight line. Okay, where the two light rays, refracted light rays, where they intersect, this will be the location. This is where you can locate the image of X. Okay, and remember here, it's not the image of A, it will be the image of X, because the rays here are coming from the top of the object. So where they are intersecting here, this will be the image of A. Okay, so you can draw the image. You can, sorry, this is the image of X. So this is the image of X, and this is the image of A. Okay, but according to our question, you have to label the image with letter Y, with letter Y. So you have to follow the instruction. You have to follow instructions. So you have to label it Y. Okay, guys, is it clear? So the image is located where the refracted rays are intersecting. Okay. Okay. Question number 2. We have here diagram showing converging lens, and you have to clearly mark and label the focal length and the principal focus, because we have principal focus at the right side and one at the left side of the lens. Use letter F. Okay, so you can label here F, or here also F. Okay, the focal length is the distance between the optical center and the focus. So you can label this. You have to draw an arrow. Okay, so this is considered as focal length, and this considered as focal length. So you have to write here focal length, or here also this is focal length. Okay, it's the distance between the optical center and, so this point at the center of the lens, this point is called optical center. Okay, the following can be used to describe the characteristics of the image formed by a lens. Okay, back to our word lost. Location, orientation, size, and type. Okay, what do you mean by location? Location means where the image will be located, or the distance between the image and the lens, or the image and the object. Orientation, the image could be upright or inverted upside down, not laterally inverted. Size, we have 3 options. It could be same size as the object, it could be enlarged, bigger, or diminished, which means smaller. Diminished means smaller in size. Okay, and the type, you know that it could be real or virtual, but for core students we have only cases for real image formed by converging lens. Okay, so you have to choose between the properties you have here, the description. What is the image formed? The image here is smaller, it's inverted, it's real, it's formed by real rays, not extension of rays. Okay, so you have to choose that it's inverted, it's also in this case diminished, smaller. What about the distance between the image and image distance greater than object distance? Image distance less than object distance. If you check here, the distance between the image and the lens, okay, this distance is smaller than the distance between the object and the lens. Okay, so this distance is called image distance, and this one is called object distance, and this distance is called image distance. It's clear if you check the diagram that image distance less than object distance. Okay, so image distance less than object distance. Okay, the last part on the figure, draw one more ray from the top of the object to the top of the image. Okay, the last ray we will draw here. You can draw extra ray because you have the 3 standard rays already drawn, so you can draw any extra ray like this, and it will be refracted at the midline, and it will intersect with the other rays here at the same point. Okay, from the top, follow the instructions. You have to draw it from the top. So this is an extra ray, and the 3 rays you have in the diagram, they are the 3 standard rays. If you check paper 1 classwork, you will find the 3 standard rays. I explained them in details.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor.